Hello, and welcome to the video on permutations. Permutations are arrangements where the order matters. We're going to have a look at a few examples to help us out with this concept. Let's say that there are 5 teams in a competition, and we want to know how many arrangements of first, second, and third there are. Let's start by drawing up 3 positions for first, second, and third. How many of the teams could come first? Well, all 5 have a chance of coming first, but once one team has come first, there are only 4 possibilities for coming second. Similarly, there are now only 3 possibilities for the team that comes third. By the multiplication principle, we know that there are going to be 5 times 4 times 3, or 60 different possible arrangements. Now, in this video, what I want to do is develop the rule for permutations as well as the use of factorial notation to make things quicker. We know that 5 times 4 times 3 is the number of arrangements we have. Now that looks really close to 5 factorial. In fact, if I just multiply that by 2 and by 1, I do get 5 factorial. I could write 5 times 4 times 3 using factorial notation by taking my multiplication and multiplying it by 2 factorial. This will change the answer though. So I would also have to divide by 2 factorial so that the value won't change. Now the numerator can be written as 5 factorial and the denominator as 2 factorial. This is much easier to write than 5 times 4 times 3. But there's no 2 in my question, so I want to be able to relate it better to the question that's been given to me. Now, we are taking 5 competitors, 3 at a time. So I want to use a 3 in my working somewhere. I know I can write 2 as 5 minus 3. The 5 is how many competitors there are, and the 3 is how many at a time that I'm taking. You're probably asking yourself, why am I trying to change the working out to something more difficult? But give me a little trust, and we'll start to see a pattern. Let's look at example 5. From a standard set of 52 cards, the hearts are taken. In how many ways can the 13 cards be arranged in a row, and how many ways can 6 of the 13 be arranged in a row? We'll start with A. We have 13 cards to arrange. Any of the 13 cards can possibly go first, so we begin with 13. Then there are only 12 cards left, so in the second position, 12 can go next, and then times 11, and then times 10, all the way down to 1. A quicker way to write this, and to work it out, is 13 factorial. I'm going to leave my answer like this because it's quite long to write out. Now we'll move on to B. It's slightly different. We don't want all 13 cards in a row, we only want 6. So we are choosing 13 cards 6 at a time. To write this out, we would write 13 times 12 times 11 times 10 times 9 times 8. There are 6 multiplications happening for an answer of 1,235,520. Now if I wanted to write this in an easier way, I'd want to use factorial notation, which it sort of looks like it is already. If I took my answer of 13 times 12 times 11 times 10 times 9 times 8 and multiplied that by 7 factorial, or 7 times 6 all the way down to 1, I would get 13 factorial. But I've changed the size of my answer. I now have to divide by 7 factorial in order to get the exact same answer. So this comes out to be 13 factorial over 7 factorial. Now in my question, 7 isn't part of it, 6 is. So I need a way to write my factorials without actually using the 7. And to do this, I notice that I'm taking 13 cards in an arrangement of 6 at a time. So the 13 and the 6 are the numbers that I want to be using. So I can write this as 13 factorial over, and I notice that 13 minus 6 is 7, and this looks very similar to the answer that we got in our last example. We're starting to see a pattern. Let's look at permutation notation. The symbol NPR means from a number of n objects, take r at a time. From our last example, 5b, we had 13 hearts to choose from, that's our n, number of objects. We wanted them 6 at a time, and that's our r, so we get 13 P6. This question is a permutation question, because the 2, 3, 4, 5, and 6, and 7 of hearts is a different arrangement to the 7, 6, 5, 4, 3, and 2 of hearts. We are choosing 6 from 13, so we write this as 13 choose 6. Writing it out the long way, we multiply 13 all the way down to 8. This is 6 multiplications, to get our answer of 1,235,520. Most calculators have an NPR button on them above the multiplication symbol. So to do this question on your calculator, simply press 13 and then shift and then times and then 6. And this will give you 13P6 on your calculator for your answer. Let's look at example 6. In how many ways can first, second and third be awarded from a class of 10? And how many ways can a math prize, a chemistry prize and a physics prize be awarded in a class of 10? They look similar, but we'll look at the language differences in just a moment. Let's look at question A. We want to know how many ways we can arrange 3 students from 10. The number of ways is going to be 10p3. This is the same as 10 times 9 times 8, which is 720. You can do this in your calculator by pressing 10p and then 3. I encourage you to use your brain though, to do as many of the multiplications as possible and use your calculator just as a check. Now question B looks similar, but there are 3 separate prizes to win. This means that the same person can win multiple prizes. So, the number of ways are going to be 10 different students can win the first prize, 10 different students can win the second prize, and 10 different students can win the third prize. This is a total of 10 cubed, or 1,000 different possible arrangements. In this part of the video, I will try to explain what NPR means algebraically with the use of examples. Let's look at the first one. 5p2 means start at 5 and multiply twice. So we start at 5 and multiply by 4, the next number down, to get an answer of 20. That's the quick and easy way about it. Let's look at 7p4. This means start at 7 and multiply down 4 times. So we get 7 times 6 times 5 and then times 4. In trying to develop the rule, I want to use factorials. So I can take my answer and multiply it by 3 factorial. In order not to change the value of it, I also have to divide by 3 factorial. So this can now be written as 7 factorial at the top and 3 factorial down the bottom. But my question is 7p4. It doesn't have a 3 in it at all. I can get the 3 by using the 7 and the 4 and using subtraction. Now, I want to show you this with another example to show that this happens all the time. So let's take 9p5. We start with 9 and multiply 5 times. To write this in factorial notation, I take my 9p5 and then I times it by 4 factorial, but then divide it by 4 factorial so that the value doesn't change. This allows me to write the top as 9 factorial and the bottom as 4 factorial. Now again, we don't have a 4, so what we need to do is make the 4 by doing 9, which is our n, take away 5, which is our r. Now, NPR means start at n, then multiply r times, going down 1 each time. So I start with n, and then I multiply by the next number down, which will be n minus 1. The next number down is n minus 2, and then n minus 3, and so on. And I can continue this on forever. But when should I stop? For 5p2, I stopped at the 4, which was the second multiplication. For 7p4, I stopped at 4 this time, but this was the fourth multiplication. For 9p5, I stopped at the 5, which was the fifth multiplication. I want to try and get something that will relate the n and the r from my question for a time when I can stop this multiplication. Now, if I subtract n minus r, I get close. In fact, I'm just 1 off. So if I add 1 to my answer, I do get my 4. Let's have a look and see if it works out for the next example. 7 minus 4 is 3, and if I add 1 to that, I get 4, which is the number that I stopped multiplying at. Let's see if it works for 9p5. 9 take away 5 is 4, and if I add 1, I get 5. Awesome, it works. So the last term in my algebra answer will be to multiply by n minus r plus 1. Now, this helps, but only if I know the sequence of numbers, and I'm not using my factorial notation yet to shorten anything. Now, my answer for the second example was 7 times 6 times 5 times 4. This is represented in my algebra that I have right now. When I wanted to write it in factorial notation, I had to multiply and divide by the same number. In this case, it was 3 factorial. For 9p5, to write in factorial notation, I had to multiply and divide by 4 factorial. I need a way of using n and r to represent these numbers. Well, I know that 3 factorial is 7 minus 4 factorial. This is just n minus r factorial. I also see that 9p5, that's 4 factorial, because it's the same as 9 minus 5 factorial, which is also n minus r factorial. So for my algebra example, if I multiply and divide by n minus r factorial, I should be able to write my answer as a shortened factorial. Multiplying the first part of my numerator and the second part of my numerator gives me n factorial. That's my top number. My denominator is written in terms of n and r already, so that's my denominator. I now have an expression for NPR in terms of n and r, and this is my rule for what NPR is. Now I know that's long and drawn out, but let's use this in an example. For example 6, we're going to use the rule for NPR to evaluate what 15p3 is. Now the rule is n factorial divided by n minus r factorial. This is 15 divided by 15 minus 3 factorial, which is 15 factorial divided by 12 factorial. This gives us an answer of 2,730. We could just go into our calculator and do 15p3, or we can do 15 factorial divided by 12 factorial. However, the algebra is very useful for showing and proving certain applications in your questions, so it's worthwhile knowing. I want to finish up looking at two different cases. What happens when r and n are the same number, and what is 0 factorial? Well, let's use this as an example. How many different arrangements of 5 letters can be made from a group of 5 without using the same letter twice? Now, we are taking n letters r at a time, and we are taking 5 letters 5 at a time. So n and r are the same number. We can write this as npn if we want to, or 5 times 4 times 3 times 2 times 1. There are 5 multiplications, which is just 5 factorial. So when n equals r, we get n factorial divided by n minus n factorial, so n instead of r, which is 5 factorial divided by 0 factorial. Now we know we want our answer to be 5 factorial, so we must be dividing by 1 to get the same answer. This leads us to the conclusion that 0 factorial has to equal 1. You're going to have to use this as an identity and remember it for future answers. That's all for the moment. The next video will be on restrictions in permutations, and we'll see what happens when there are certain things that you're not allowed to do or certain things that you have to do in order to work out your arrangements. Good luck.